Hey everybody, the purpose of this video is to get you some solutions to the Johns Hopkins hypothesis test involving red and blue or blue and yellow circle identification and the results from that. So what I'm here is I'm just going to fill out this template sheet for us so that we can get ourselves some understanding of that. We are testing to see how you guys do with respect to this 75% that Johns Hopkins claim. They think that people get around 75%. So we're going to test a proportion, obviously, because it's a percentage. And we're checking the percentage correctness, I guess, that you get. And that's what we're looking at. How did you do? We're treating you as a random sample of yourself. Obviously, what you'd want to do is you'd want to pool these results with your entire class, which maybe we'll do if I remember to actually do this in class with you guys. I think you will do better than the 75% that Johns Hopkins claims. That's my claim. Now let's see what the opposite of that is going to be. It's either going to be less than or equal to. This is your alternative hypothesis. You can say it that way. Very often you'll see P is equal to 0.75. That's also used. Some of you guys have been very clever about just saying it's not greater than, and I love that. You're thinking mathematically. Totally rad. So anyway, you're testing that it's greater than. That's the idea. Your two possible types of error. Well, type 1 would be saying we did better than 75% when in fact we didn't. That's saying we did better when in fact we didn't. That's a type 1 for sure. It's exactly what it is, a false positive. A false negative would be saying we didn't do better. We didn't do better than 75% when in fact we did. There's a type 2. I'll let you decide which one you think is worse. I think crying wolf would be a little bit worse because you're touting something that doesn't exist. But then again, people have argued probably at this point that it doesn't matter which one it is because it's meaningless data. That's fair too. Just give me your opinion on one of them. Which distribution is definitely a Z, that's for sure. And a test statistic in the variable. This is going to be varying, speaking of variable, dependent on you because it depends on how you did. So what I'll do is I'll throw you some examples. We're testing against 75%. If you got exactly 75% of them correct, that means you would have gotten 15 out of 20 correct. And you are testing for a greater than. And you might be able to guess the p-value of 0.5 because that means you would have landed exactly at average and shaded to the right. So if you got exactly 15 out of 20 correct, your test statistic would be 0, landed at average, and the p-value would be 0.5. Maybe you didn't. Maybe you got more correct. Maybe you got 17 out of 20 correct. This would be above average, which means you're going to have a smaller p-value. Your Z is about 1 standard deviation up 15%. Okay? Hopefully you realize if you get less than 15%, you're going to get a p-value above 0.5. So what we're looking for now maybe you got them all right. That's quite possible too, right? It's quite possible you get them all right. Maybe you get 20 out of 20 right. Oh, I can't get 21 out of 20. 20 out of 20 right. And if that happens, you've got a p-value of about 0.5%, 2.5 standard deviations up. So here's the deal. I don't know what you're going to get here. It's going to be Z equals something. I do know that. It has to be that, and this is going to be P equals something, and it's got to be that. If your Z is outside, I believe, of 1.645, you're going to have a p-value that's less than 5%. Otherwise, it'll be bigger than 5%. So as far as the correct phrasing and completing the conclusion, you're either going to have appears if you got a p-value that's less than 5%, or it does not appear if you got it greater than 5%. The conclusion should be the same though. I scored higher than 75% correctness. Or I will score. I guess I should say I will score higher because the idea is you're trying to see if you can predict from this. Okay? So if you got a small p-value, it's going to be appears. That'll also be a type 1 error down here. If you got a big p-value, that'll be does not appear, and it'll be a type 2 error. So, I'm sorry for the kind of, it's a little bit hand-wavy hocus-pocusy, but it really does depend on what you guys got in your data. So, hopefully that makes sense, and we'll catch you in class.